So we wanted to hear all these different analysts, what they're thinking, where they're coming from. But most important, of course, is Jensen Huang. Honestly, NVIDIA, that's the one that matters more. The rest are just kind of institutional analysts. So let's, when you listen closely to Jensen Huang, what he's predicting, it all ties back to Tesla. And you had a tweet, you're kind of explaining that that's the case. Let's start first with this. AI investor posted a video of Jensen actually just being interviewed recently. And he said, what does it mean for NVIDIA's revenue when Jensen said inference will go up by 1 billion times? So in this interview, Jensen's saying that not only NVIDIA's revenue, but again, you'll explain what does it mean for Tesla if this goes up. So let's watch this.
Over 40% of your revenue today is inference. But inference is about ready because of chain of reasoning.
Yeah.
Right?
It's about to go up by 1 billion times.
Right, by a million X, by a billion X.
That's right. That's the part that most people haven't completely internalized. This is that industry we were talking about, but this is the industrial revolution.
Right. That's the production of intelligence.
That's right.
Right? And
it's going to go up 1 billion times.
Right. And so, everybody's so hyper-focused on NVIDIA as kind of like doing training on bigger models.
Yeah.
Right? Isn't it the case that your revenue, if it's 50-50 today, you're going to do way more inference in the future?
Yeah.
Right? Then, I mean, training will always be important, but just the growth of inference is going to be way larger than the growth in training.
We hope.
It's almost impossible to conceive otherwise.
Yeah, we hope. That's right. That's right. Yeah. I mean, it's good to go to school.
Yes.
But the goal is so that you can be productive in society later. And so it's good that we train these models, but the goal is to inference them.
And then you had this post that said that Tesla designs their own AI inference chips, all of the hardware and software for them. They're used in all Tesla cars and Optimus.
Yeah, Tesla equals NVIDIA when it comes to inference. So let me explain that. I'm not saying in terms of AI footprint that they're equivalent, because NVIDIA is obviously serving the world on this. What I mean is six or more years ago, Elon and the Tesla team, they made a bet. And you have work that's done on the training side, you have work that's done on the inference side, and you have requirements and capabilities, in this case for a self-driving vehicle and eventually a humanoid robot. And Tesla, even today on the record, says that they can't, so let me be very clear what they do. NVIDIA designs inference hardware, silicon, and the surrounding computer around it if a customer needs it. And they design the software as well to interoperate with that. And they sell that to people. They don't, NVIDIA does not have their own fab, so they design this and they send it out to TSMC. TSMC does their production, and then customers buy that production from them, through TSMC. But NVIDIA does the hardware and software for inference. But in the case of Tesla, Tesla used to buy their inference from NVIDIA, but they branched off and did their own. This is the Pete Bannon team and the team that they ramped up several years ago. And this is where, you have hardware 3 AI 3 and the AI 4 chip in vehicles today and the coming AI 5 chip. What is that? Tesla designs that chip. Okay. They design the software and the computer around that chip and all the interoperability. That is all Tesla designed. They do the same thing. They send it out to NVIDIA or Samsung, who's also a fab, and they get their parts fabricated, and they're sent back. They're put on the computer printed circuit board assembly, and they're sent back as a computer, as a full computer, and put into Tesla vehicles. This board. So I want to be very clear there, that literally Tesla does not buy inference from NVIDIA. Tesla does this themselves, and we'll be now in the 7 millionth Tesla by the time they complete production this quarter, and it's going to be in every Optimus, and then any other, call it edge device. These are the things that actually interact in the world with real people and do real work, and so these devices see things and they do localized processing. That's what that inference is. And Tesla does this themselves. I think it's really important because even most analysts and on-air personalities don't understand this simple fact that Tesla does this themselves. And so when you start talking about FSD, and you start talking about FSD unsupervised, supervised, unsupervised, the robotaxi and so forth, as that scale, that is all local inferencing from Tesla. And Tesla's even talked about the AI4 computer and the AI5 computer making its way over to the training side to do some of the training tasks as well. So Tesla is a partner with NVIDIA today. They are buying compute from NVIDIA. They've made the largest clusters in the world, this 100,000 unit GPU cluster we're going to talk about in a minute. So they're definitely partners. They definitely like working with each other, and they definitely both need each other. But when it comes to the inference side, and this is where the big debate now is in the industry, is where is the AI workload going to go, and where is it going to transition to? And I think what you heard Jensen say is that there's going to be massive growth on the inference side. Tesla does their own inference.
Every time a mother comes to me, the first question is, why me? Why did God punish me? But as she starts to understand her child, her acceptance.
Appreciate it, Jeff. That's so big deal. And again, I'm completely underestimating this, because here you've got NVIDIA, Jensen Huang, saying inference compute is going to go up 1 billion times. And what you've just said is Tesla also creates inference compute. And so, yes, NVIDIA is going to benefit from it, but so is Tesla. And then even Jensen says, what matters more is not the training. Eventually, it's the students who actually do something with it, which is what Tesla does. They actually do something with this in the inference side. So
let me give one more piece of the puzzle, quick piece of the puzzle too, Herbert. Why is this important? Look at NVIDIA's gross margins today. They're at roughly 75%. If you wanted to do inference on your vehicle, you're going to buy software from them, and you're going to buy the hardware, the chip from them. And together, you're going to pay out 75 points of gross margin to get it. Guess what Tesla's paying out? Tesla does not pay that. They make their own software, and in terms of the hardware itself, of course they have to pay TSMC or Samsung from a fab perspective, but it's not the 75% gross margin. So when you start we had the conversation about the cybercab and how do you minimize the cost structure on that. Others are never going to be able to get over that fact of buying their inference from someone else. That is going to be a line in their unit economics, and they're going to pay out that gross margin. They're going to be paying a license for the software. They're going to be paying out for that hardware margin as well. Tesla's not going to have those lines in their unit economics. So when you start talking about the time to economic scale, when you start putting out millions of humanoids and you start to put out millions of these vehicles, you take this massive line out of the unit economics. Tesla's going to get to economic scale faster just by definition of this alone.
Yeah. So not only is vertical integration one of Tesla's superpowers, the other really big one is just time to market, how fast they can get there. And here's Jensen Huang. If you don't believe Elon or Tesla, listen to what Jensen Huang tells you of his experience working with Elon and the team. You made sure that people saw this, and he said, Jensen Huang talks about that typically most companies will take 1 year, but it only took 19 days, 2.5 weeks. And you're saying that time to value is a cheat code, not understood by most. Clearly the priority at Musk companies from the leader, very straight from Jensen. So,
and the first of all, acknowledgement of achievement where it's deserved. From the moment of concept to a data center that's ready for NVIDIA to have our gear there, to the moment that we powered it on, had it all hooked up, and it did its first training.
Yeah.
Okay.
True.
So that first part, just building a massive factory, liquid cooled, energized, permitted, in the short time that was done. I mean, that is like superhuman. Right. Yeah, and as far as I know, there's only one person in the world who could do that. Right. You know, I mean, Elon is singular in this understanding of engineering and construction and large systems and marshaling resources.
Incredible.
Yeah, just it's unbelievable. And and then, and of course, then his engineering team is extraordinary. I mean, the software team's great, the networking team's great, the infrastructure team is great. You know, Elon understands this deeply. And from the moment that we decided to go, the planning of with our engineering team, our networking team, our infrastructure computing team, the software team, all of the preparation in advance, then all of the infrastructure, all of the logistics and the amount of technology and equipment that came in on that day, NVIDIA's infrastructure and computing infrastructure and all that technology, to training, 19 days. You just, you know what, you don't want.
Did anybody sleep? 24/7.
No question that nobody slept. But first of all, yeah, 19 days is incredible. But it's also kind of nice to just take a step back and just, do you know how many days 19 days is? It's just a couple of weeks.
Right.
And the mountain of technology, if you were to see it, is unbelievable. All of the wiring and the networking and, you know, networking NVIDIA gear is very different than networking hyperscale data centers, okay? The number of wires that goes in one node, the back of a computer is all wires. And just getting this mountain of technology integrated and all the software, incredible.
Right.
Yeah, so I think what Elon and the X team did, and I'm really appreciative that he acknowledges the engineering work that we did with him and the planning work and all that stuff. But what they achieved is singular, never been done before. Just to put in perspective, 100,000 GPUs. That's, you know, easily the fastest supercomputer on the planet as one cluster. A supercomputer that you would build would take normally 3 years to plan.
Right.
And then they deliver the equipment, and it takes 1 year to get it all working.
Yes.
We're talking about 19 days.
Wow.
What's the credit of the NVIDIA platform, right? That it's, the whole processes are hardened.
That's right.
Yeah.
Everything's already working, and of course there's a whole bunch of, you know, X algorithms and X framework and X stack and things like that. And we got a ton of integration we have to do, but the planning of it was extraordinary. Just pre-planning of it to, you know.
N of one.
Jeff?
This is something that a lot of companies don't spend time on, and they don't focus on it. A lot of companies traditionally focus on how much am I paying for a part and how much can I get that cost lower. And you should be focused on that. You should be focused on eliminating the part if you can. But this whole concept of I've acquired capital, in this case 100,000 GPUs, $4 billion, I guess. And how long does it take me to get to from the money that left our bank account to go buy those GPUs? How long does it take before they're actually installed and processing meaningful output that's actually going to start generating revenue for my company? And that is the mental model, and probably the physical model, I should say, that Elon has in his head. And what he does is he tries to figure out how to cut that time out. If you study Tesla's history and you study who they hire, they have hired, Tom Zhu, for example. His background wasn't in building cars. His background was in building factories, and how do you build them faster and faster in each iteration? That is his specialty, and now he's obviously developed the automotive specialty. The automation team that they acquired in Germany. Tesla is acquiring companies, not all the companies, but there are acquisitions that they have made, there are hires that they've made that focused on the total process time, in terms of getting a return on your capital, whether it's building factories or what have you, or the automation piece of it, which is obviously also trying to accelerate and minimize cost structure and accelerate return on invested capital, ROIC. So what Jensen is explaining here is that there is no single person. When you think about, he talked about 3 years of planning for a data center, another year for construction and bring up, and to have, at least the 1 year portion of it that, done in 19 days in the case of X, and what Tesla is doing as well on the Colossus Supercluster. I mean, this is extraordinary. No one's even close. So other companies are going to look at this and say, all right, we've got to really start spending mental capacity on this and figuring out how can we do better. here as well. But this, this is just another example of showing how and Elon is a great steward of capital. And the thing is how much is minimizing that network time from the capital going out to it coming back and actually producing useful output for your company. So I can't overemphasize the importance of this. It's not just how much you pay for stuff and how much margin and so forth. It's also, this is the cash piece. This is the cost of capital piece. And this transcends everywhere in the company, whether they're buying CapEx for production lines. This is why they're extending the 3 and Y CapEx out and producing the new interim lower cost vehicles. That was a play on reducing both unit economics and reducing the cost of capital and getting greater return on capital. And all these decisions are connected together, but this is a competitive advantage. And now these are AI factories. Okay, those data centers are a factory, okay, where information or video, whatever comes in as an input, and the output are these training models. And Elon viewed it just like there's a car factory or there's you name a Starlink. He viewed this as another factory, and if I can bring the factory up faster and I can get it producing meaningful output faster, it's going to be better for my cash, it's going to be better for my cost structure, and it's going to give me a competitive advantage over everyone else. And that's what Jensen, who sees all of his customers, he sees Amazon, he sees Meta, he sees all these other customers, he sees what they're doing with his GPUs, and then he sees what Elon is doing with his companies, and he's specifically calling that out here.
ऐसे मैं स्टॉक को सिलेक्ट करता हूँ, कहाँ पे एंट्री करना है, कहाँ पे एग्जिट करना है.
You definitely won't believe the 200,000. He's part of it is just not only, he's already done this in 19 days. Everybody is much slower, but he's gonna keep doing it, and he's gonna just separate the spread of how much faster they are. Elon said this, which was kind of interesting. He goes, for my time-based predictions, I generally aim for the 50 percentile date, which means that half my predictions will be late and half will be early. The press never mentions the predictions that were early, so it seems like I'm always late. However, it's very rare that a prediction I make does not come true over time. So,
yeah,
that's how
I
he
commented
thinks
on
of
this too. I commented on this too because this is something I've in my career I've always been asked to not only weigh in on but create. I was asked of when are we going to have 2 million of this smartphone available on the shelf, and I have to give a date. And the reason I have to give a date is because there's marketing plans that are around it. There's hundreds of millions of dollars that are being spent, and of course there's purchasing decisions that are being made, and how much cash can the company have outlaid without actually producing sales. And so I would be in this position 12 months out that I'd have to give a date, or at least a week, when I believe that we're going to achieve it. And I will tell you that when you have a schedule, when you're building a product that has many things in it that have never been done before in the industry, it increases the variation on that schedule dramatically. But if you're producing an iterative product, let's say you're adding a camera button or you're doing something iterative to a product, those schedules are much more predictable, and they can even get them down to the day. Certainly the week, but certainly and down to the day. And you're not just predicting the day when the first unit ships.
Right.
You have to predict the velocity of the factory and the supply chain. It's very important. Shipping, nobody cares if you shipped one unit. They want to know when you're getting to your peak run rate, and that's what the whole economics of the everything is weighed upon. So what the products that he is building, and he's asked to give a date. Here's what he's doing. He is providing a date that he knows he's picking the 50 percentile. He's trying to be aggressive, and he's trying to motivate his teams to think differently, to do things differently, to work closer together. If you've studied or if you've looked at how Tesla works, they have conventional departments. They have supplier realization department, but they don't just sit like in that whole group is not just sitting in one room and waiting for inputs from engineering and outputs from here. They go work together as one team. So that supplier realization engineer that's supposed to figure out how to get that part made at a supplier is not just sitting with all of his supplier or her supplier realization buddies in that room. They're like, what part am I working on? If I'm working on the electric motor, they sit with the electric motor team, the design engineers, the software people, they all sit together, and that accelerates the schedule in a way. Putting these aggressive schedules out forces these groups to work together organically. And I think we talked about this in a prior episode a bit, but they're organized differently, they work differently. So Elon's got to give schedules that motivate and drive his teams, you know, to do things differently in each iterative product, so they can get faster and faster. And at the same time, the other competing force in his schedule proclamations are how many new things are they doing that have never been done before in the industry before. And when you're trying to give a schedule for that, this is like documented facts, and I've had this documented from my own, experience as well. The schedule variation on landing those components or landing those systems or the whole product, there's a direct correlation to how many new and unique or different things you're doing in the product versus how many things have been done before. And the things that have been done before, you could nail it. You could nail it within a couple of days. In fact, you should be figuring out how to do those things faster. The stuff that has never been done before has the higher variation in it. And that's sometimes where they get caught up. But that's what's happening. Tesla does products that have a lot more variation because they're going after things they've never done before. And when they did the first casting, when they did the first integrated, seats or the one-piece version, they're doing things that haven't been done before in the industry that they're in, or they haven't been done at scale before. In the industry, there's been castings that have been done before. They've never been done at the scale or the size of what they're doing. So that's what's happening when I saw that post. I'm like, to me, it's like, it's okay because you're going after things that have never been done before.
Is so good that even when the competitors' chips are free, it's not cheap enough. In the last 10 years, we reduced the cost of computing by 1 million times. The cost of deep learning by 1 million times. If we could reduce the marginal cost of computing down to approximately zero, we might use it to do something insanely amazing. Large language models. To literally extract all of digital human knowledge from the internet and put it into a computer and let it go figure out what the knowledge is. That idea of scraping the entire internet and putting it in one computer and let the computer figure out what the program is an insane concept. But you wouldn't ever consider doing it unless the marginal cost of computing was zero. We made that breakthrough. And now we've enabled this new way of doing software. Imagine, for all the people that are still new to artificial intelligence, we've figured out how to use a computer to understand the meaning, not the pattern, but the meaning of almost all digital knowledge. And anything you can digitize, we can understand the meaning. So let me give you an example. Gene sequencing is digitizing genes. But now with large language models, we can go learn the meaning of that gene. We can understand what's the meaning of a cell. A whole bunch of genes that are connected together. And since this is, from a computer's perspective, no different than a whole page of words, and you asked it to summarize. What did it say? Summarize it for me. What's the meaning? This is no different than a long page of genes. What's the meaning of that? Big, long page of proteins. What's the meaning of that? That AI, which was enabled by this new form of computing we call accelerated computing that took 3 decades to do, is probably the single greatest invention of the technology industry. This will likely be the most important thing in the 21st century.
The GPU chip that is behind artificial intelligence right now is your H100, and I know you're introducing an H200. And I think I read that you plan to upgrade that each year. And so could you think ahead 5 years, March 2029, you're introducing the H700. Right. What will it allow us to do that we can't do now?
Let me first say something about the chip that John just described. As we say a chip, all of you in the audience probably, you would imagine there's a chip kind of like, like this. The chip that John just described weighs 70 pounds. It consists of 35,000 parts. 8 of those parts came from TSMC. That one chip replaces a data center of old CPUs like this into one computer. The savings of that one computer is incredible, and yet it's the most expensive computer the world's ever seen. It's $250,000 per chip. We sell the world's first $250,000 chip. But the system that it replaced, the cables alone cost more than the chip, this H100. The cables of connecting all those old computers. That's the incredible thing that we did. We took this entire data center, we shrunk it into this one chip. The way that this chip works, it works not just at the chip level, but it works at the chip level and the algorithm level and the data center level. It doesn't do all of its work by itself. It works as a team. And so you connect a whole bunch of these things together, and networking is part of it, and it computes at data center scales. And together, what's going to happen in the next 10 years, say, John, we'll increase the computational capability for deep learning by another 1,000,000 times. What happens when you do that? Today, we kind of learn, and then we apply it. We go train, inference. We learn, and we apply it. In the future, we'll have continuous learning. The training process and the inference process, the training process and the deployment process, application process will just become one. Well, that's exactly what we do. You know, we don't have like between now and 7 o'clock in the morning, I'm going to be doing my learning, and then after that, I'll just be doing inference. You're learning and inferencing all the time. And that reinforcement learning loop will be continuous. And that reinforcement learning will be grounded with real-world data through interaction, as well as synthetically generated data that we're creating in real time. So this computer will be imagining all the time. It'll do synthetic data generation, it'll do reinforcement learning, it'll continue to be grounded by real-world experiences, it'll imagine some things, it'll test it with real-world experience, it'll be grounded by that, and that entire loop is just one giant loop. That's what happens when you can compute for a 1,000,000 times cheaper than today. And so as I'm saying this, notice what's at the core of it. When you can drive the marginal cost of computing down to zero, then there are many new ways of doing something you're willing to do. This is no different than I'm willing to go further places because the marginal cost of transportation has gone to zero. I can fly from here to New York relatively cheaply. If it would have taken a month, I'll probably never go. And so it's exactly the same in transportation and just about everything that we do. And so we're going to take the marginal cost of computing down to approximately zero. As a result, we'll do a lot more computation.
As you probably know, there have been some recent stories that NVIDIA will face more competition in the inference market than it has in the training market. But what you're saying is it's actually going to be one market, I think. Is there going to be a separate training chip market and inference chip market, or it sounds like you're going to be continuously training and switching to inference, maybe within one chip? I don't know. Why don't you explain some more?
Well, today, whenever you prompt an AI, it could be ChatGPT or it could be Copilot. Whenever you're prompting, it's doing inference. So it's generating information for you. Whenever you do that, what's behind it, 100% of them, is NVIDIA's GPUs. And so NVIDIA's, most of the time you engage our platforms are when you're inferencing. And so 100% of the world's inferencing today is NVIDIA. Now, is inferencing hard or easy? The reason why people are picking on inference is when you look at training and you look at an NVIDIA system doing training, when you just look at it, you go, that looks too hard. I'm not going to go do that. I'm a chip company. That doesn't look like a chip. A lot of competitors tend to say, we're not into training, we're into inference. Inference is incredibly hard. The hard part of inference is the goal of somebody who's doing inference is to engage a lot more users, to apply that software to a large installed base. Inference is an installed base problem. This is no different than somebody who's writing an application on an iPhone. The reason why they do so is because iPhone has such a large install base. Almost everyone has one. And so if you wrote an application for that phone, it's going to be able to benefit everybody. Well, in the case of NVIDIA, our accelerated computing platform is the only accelerated computing platform that's literally everywhere. And because we've been working on it for so long, if you wrote an application for inference, and you take that model and you deploy it on NVIDIA's architecture, it literally runs everywhere. And that takes enormous patience and years of success and dedication to architecture compatibility, so on and so forth.
You make completely state-of-the-art chips. Is it possible, though, that you'll face competition that claims to be good enough? Not as good as NVIDIA, but good enough, and much cheaper. Is that a threat?
We have more competition than anyone on the planet has competition. Not only do we have competition from competitors, we have competition from our customers. And I'm the only competitor to a customer, fully knowing they're about to design a chip to replace ours. And I show them not only what my current chip is, I show them what my next chip is, and I'll show them what my chip after that is. If a customer can do something specifically that's more cost effective, quite frankly, I'm even surprised by that. And the reason for that is this. When you see computers these days, it's not a computer like a laptop, it's a computer, it's a data center. And you have to operate it. And so people who buy and sell chips think about the price of chips. People who operate data centers think about the cost of operations. Our time to deployment, our performance, our utilization, our flexibility across all these different applications, in total, allows our operations cost, they call it total cost of operations, TCO. Our TCO is so good that even when the competitors' chips are free, it's not cheap enough. And that is our goal, to add so much value that the alternative is not about cost. I was hoping not to sound competitive, but John asked a question that kind of triggered a competitive gene. And I came across, I want to apologize, I came across, if you will, a little competitive. But he surprised me with a competitive. I thought I was in an economic forum.
Could you just dive a little deeper into what you see as AI's role in drug discovery?
The first role is to understand the meaning of the digital information that we have. The question is now, what is the meaning of that protein? What is the meaning of this protein? What is this function? As you guys know, you can chat with a PDF. My favorites are you take a PDF file of a research paper and you load it into ChatGPT. It's like talking to the researchers. What inspired this research? What problem does it solve? What was the breakthrough? What was the state of art before then? In the future, we're going to take a protein, put it into ChatGPT just like PDF. What are you for? What enzymes activate you? What makes you happy? And so that's one of the most profound things we can do, is to understand the meaning of biology. Does that make sense? If we can understand the meaning of biology, as you guys know, once we understand the meaning of almost any information that it's in the world of computer science, in the world of computing, amazing engineers and amazing scientists know exactly what to do with it. But that's the breakthrough.
Boy, Oregon State and Stanford are really proud of you. Stanford has a lot of aspiring entrepreneurs, students that are entrepreneurs, and maybe they're computer science majors or engineering majors of some sort.
Please don't build GPUs.
What advice would you give them to improve their chances of success?
I think one of my great advantages is that I have very low expectations. Most of the Stanford graduates have very high expectations. And you deserve to have high expectations because you came from a great school. You were very successful. You're surrounded by other kids that are just incredible. You naturally have very high expectations. People with very high expectations have very low resilience. And unfortunately, resilience matters in success. I don't know how to teach it to you except for I hope suffering happens to you. And to this day, I use the phrase pain and suffering inside our company with great glee. And I mean that. Boy, this is going to cause a lot of pain and suffering. And I mean that in a happy way. Because you want to refine the character of your company. You want greatness out of them. And greatness is not intelligence, as you know. Greatness comes from character, and character isn't formed out of smart people. It's formed out of people who suffered. For all of you Stanford students, I wish upon you, ample doses of pain and suffering.
I have a couple questions.